If CVE 2026-8711 flagged your Windows NGINX deployment, here's how to prove whether you need an urgent NJS patch or can document it as out of scope. You'll identify the NGINX instance actually serving traffic, trace its loaded configuration, and test for the complete vulnerable pattern. You'll also inventory containers and WSL, so a less obvious NGINX deployment doesn't escape review. You should not treat CVE 2026-8711 as a vulnerability in every NGINX server. It affects NGINX JavaScript NJS versions 0.9.4 through 0.9.8, while NJS 0.9.9 or later contains the fix. Exposure requires imported JavaScript, the affected proxy directive, client-influenced variables, and JavaScript fetch behavior to exist together. If the active configuration has no JS import, the NJS specific path is generally out of scope. If every condition exists, you should patch promptly. The dangerous path begins when JS fetch proxy incorporates values that a remote client can influence. The $HTTP family exposes request headers, $arg exposes query string arguments, and $cookie exposes cookies. When a location's imported NJS handler invokes ngx.fetch, affected versions can mishandle this precise combination and produce a heap buffer overflow inside the worker process. ngx.fetch itself supports legitimate routing and service composition designs. The risk comes from this version-specific interaction with client-derived proxy values. Your primary operational concern is denial of service. A crafted, unauthenticated request may crash an NGINX worker. Repeated attempts can create restarts, intermittent failures, failed API calls, broken sign-ins, or unstable routing, even when the applications behind the proxy remain healthy. Remote code execution is possible only under narrower circumstances, including when ASLR is disabled or bypassed, so you should not describe it as automatic. Still, unauthenticated memory corruption in an internet-facing edge process warrants prompt remediation when the complete pattern exists. Administrative access lets you inspect system-level NGINX launch details without permission barriers. Open Start. Type CMD, right-click Command Prompt, and choose Run as Administrator. The shield identifies the elevated option. If that choice is missing, sign in with an administrator account or ask your system administrator to authorize the session. User Account Control now verifies that you intend to grant the console administrator rights. Check that the prompt identifies Command Prompt, then click Yes to continue into the elevated window. If you cannot approve it or credentials are requested, use an authorized administrator account rather than bypassing UAC. A Windows service can reveal the executable and arguments that identify the active NGINX configuration. In PowerShell, run the displayed getKim instance, Win32 service pipeline, and review name, display name, state, and especially path name. If no service appears, NGINX may run as a foreground process, container, WSL workload, scheduled process, or vendor-managed bundle. A running nginx.exe process can expose launch arguments even when no matching Windows service exists. Run the displayed Win32 process pipeline and inspect each process ID and command line for the executable path plus any -p or -c arguments. If command prompt reports that getSim instance is unrecognized, run this PowerShell command from PowerShell instead. Defining the root keeps your search focused on the NGINX tree you identified, instead of unrelated backups or templates. Set $root to C NGINX exactly as shown, replacing that value when your active service or process uses another location. Keep the same PowerShell session open, because $root will not carry into a newly opened console. This recursive search collects evidence for every configuration element involved in the vulnerable pattern. Run the pipeline to find JS import, JS fetch proxy, ngx fetch, and the $HTTP, $arg cookie, variable families, with each result showing its path, line number, and text. If results seem incomplete, verify $root, and separately search any include paths located outside that tree. The -T option prints the configuration NGINX actually resolves, including included files, which helps distinguish active settings from unused copies. Run the displayed NGINX command and inspect its output for the same NJS directives and include paths. If the executable is elsewhere or the command loads the wrong configuration, use the exact path and launch arguments discovered earlier. This check mirrors a deployment that explicitly uses C:\nginx as its prefix and conf-nginx.conf as its configuration file. Run the displayed command with -p, -c, and -t. Then compare the printed configuration with the files you searched. If your service path name uses different values, substitute those exact values, because a mismatched prefix can produce misleading output or a configuration error. NGINX may be running inside a container even when no native Windows process or service provides the answer. Run docker ps with the displayed table format to list container IDs, images, names, and published ports. Then identify likely proxy workloads. If Docker is unavailable or the list is empty, confirm you are using the correct Docker context and that stopped containers are not part of the deployment. WSL can host a separate Linux-side NGINX configuration that a Windows file search will not prove active. Run WSL-L-V and note each distribution, its state, and its WSL version before inspecting the relevant distribution's Linux configuration. If no distributions appear, WSL is not part of this host's current inventory. If one does, do not assume C:\nginx represents its active files. You now have the evidence needed to patch affected NJS deployments or close CVE 2026-8711 accurately when the JavaScript path is inactive. Join the discussion thread on windowsforum.com for questions, updates, and help applying these checks to your specific setup.